The Earth's rotation on its axis causes day and night on Earth. An axis is an imaginary line that runs through the center of a sphere. The Earth's axis passes through the North Pole and the South Pole. As the Earth rotates on its axis, different parts of the Earth face toward and away from the sun. When we are facing toward the sun, it is day. When we are facing away from the sun, it is night. Scientists believe the Earth spins on its axis because of how our solar system formed 4.5 billion years ago. According to the theory, our solar system started as a giant cloud of hydrogen and helium. A disruption near the cloud, possibly an exploding supernova, disturbed the cloud and it started spinning. Space is a vacuum, so there's no friction. Once something starts spinning, it will continue to turn unless an outside force stops it. Everything in our solar system formed from that cloud of gas, so it all spins. Even the sun spins on its axis at about 720,000 kilometers per hour. The speed of the Earth's rotation is about 1,700 kilometers per hour at the equator. Because the Earth and Sun are spheres, the differences in circumferences mean that their rotation speeds are different at the equators and the poles. Currently, one day on Earth lasts for 24 hours. It actually only takes 23 hours, 56 minutes, and 4 seconds for the Earth to make a complete rotation. But the Earth's position shifts as it revolves around the Sun. As a result, the Earth has to rotate a little bit more than once to complete a full circle with respect to the Sun. While one day is currently 24 hours on Earth, this wasn't always the case. When the Earth first formed, it rotated much faster. A day was about 7 hours long. Around 620 million years ago, a day was 22 hours long. The Earth's rotation is slowing by an average of 1.8 milliseconds per century. The primary cause of the Earth's slowing rotation is the relationship between the Earth and the Moon. The gravity of the Moon pulls the Earth toward it. The Moon's gravity creates a slight bulge on the side of the Earth facing the Moon. The Earth's spinning pushes the bulge in front of the Moon, and the Moon pulls back on it. The Moon's pulling slows down the Earth's rotation. The pulling also pushes the Moon farther away from the Earth. Each year, the Moon gets about 1.5 inches farther away from the planet. The Moon isn't the only thing affecting the Earth's rotation. The sloshing around of the Earth's liquid outer core, wind and waves on Earth's surface, seismic activity, and even the melting ice caps change the Earth's rotation. Some things slow it down and others speed it up, but overall, the Earth's rotation is slowing. The Earth's rotation is also affected by Earth's distance from the Sun. The Earth has an elliptical orbit around the Sun. When it is winter in the northern hemisphere, the Earth is closer to the Sun, and when it is summer in the northern hemisphere, the Earth is farther away from the Sun. The Earth moves faster in its orbit when it is closer to the Sun. As a result, its rotation slows. Summer days really do pass more quickly than winter days, but only by a fraction of a second. Understanding that day and night are caused by Earth's rotation is a relatively recent advancement in science. If you watch the sun move across the sky during the day, it looks like the sun is revolving around the Earth. We call this a geocentric model of the solar system. Nicholas Copernicus, a Polish priest, studied the skies and came up with a heliocentric model of the solar system. He believed that the Earth was just one of the planets that orbited around the sun. He published his theory in 1543, but died from a stroke in the same year. In 1632, Galileo Galilei, an Italian astronomer, published his book confirming Copernicus's theory about the heliocentric solar system. In 1633, the Catholic Church put Galileo on trial for heresy and sentenced him to house arrest for the rest of his life. The Catholic Church didn't officially recognize heliocentrism until 1822. Today, we have the technology to watch the Earth rotate on its axis in space. We can measure the length of a day to the nearest fraction of a millisecond. Maybe someday we will be comparing the days on Earth with the days on another planet orbiting another star.